Welcome to Hope Academy. My name is Mr. O, and today I'm going to be going over a concept called the remainder theorem. Remainder theorem. So when we are discussing around the concept of remainder theorem, there's a purpose for the remainder theorem. The purpose of a remainder theorem is to find out roots or factors, or we could call it the x-intercept. There's a lot of different terms for this. X-intercept or the zero. So the point is that in an efficient way, efficient/fast way. So in a prior video, I did cover long division. Long division does help me find the root or factor or the x-intercept and whatever not. But the part is that it does take a lot of time. And if you do certain long division problems that involve x to the 5th, x to the 8th, it could go crazy. Well, long division is going to take too much time, especially if you're given a lot of different roots to deal with. And so what remainder theorem does is that it sort of lets you bypass that and compute it as fast as possible so that you don't have to work through all of that. And so I'm going to provide a simple example today that sort of explains why the long division format could work. It is a viable option, but remainder theorem is actually a lot easier for you to figure out. And so let's say that we were given a question like this. So let's say it's x squared plus, let's say, 5x plus 4. And we were told it's divided by x plus 1. And we're wondering. So the first thing we have to understand is that, well, we don't know right off, unless you know mental math and you're very good with factoring on top of your head. But usually, people will not know whether or not this value is going to be very clean division to this. So what I mean by that is that we don't know whether or not this part is going to be a factor of x squared plus 5x plus 4. And so I'm going to show the different methods in which it proves that this is going to be a factor, but how the remainder theorem method will let you get to the answer faster than these different methods. So for example, if I was to factor this value, right, I could do like the box method, for example. So a lot of times when I'm doing this type of question, I know this x squared plus 5x plus 4. I know that this is going to be multiples of x, and I know this is going to be plus 4 plus 1 because it will be 4x. And x, I'm breathing through this a little bit, but you'll realize that if I factor this x squared plus 5x plus 4, it will be x plus 4, x plus 1. And so based off of this, the box method, which I did based on this concept, you'll see that x plus 1, if I divide by x plus 1, will cancel out very cleanly. So I know it is a factor. It is a factor. Yay. But the point is that that's not the important thing that I wanted to go for. So that's one method, and sometimes factoring does take time, and sometimes, especially when you get to the higher levels like x to the 4th, x to the 5th, maybe even x to the 6th, you cannot factor like this because the factoring box method and different methods like this are limited in their capability to do this. So that's why this method is not the best method per se. Another method to prove whether or not it's a factor is by dividing. So very simply doing x plus 1 divided by, and this is the long division format, x squared plus 5x plus 4, I could go through the process of actually solving this again. And so, for example, x times x, which is going to be x squared plus x, and I'm going to subtract these, and what's going to happen, these cancel out, so it'll be 4x plus 4, and I'm going to do plus 4 here, and I find out that this will be 4x plus 4, and I'm going over this quickly because it's not my main focus. I just wanted to prove that what happens is that because my remainder is 0, I know that x plus 4, this x plus 1 is for certain going to be a factor of x plus 4. So it is a factor. I'm going to write that again. It is a factor, woohoo. But the idea is that this is not even the easiest way again. This still took me some time to do this. This long division process is possible for me to do for any polynomial, whether it's x to the 6th, x to the 7th, whatever not. But the problem is that this is not the easiest way, and it will take you a lot of time if you were given like 8 different possible roots to work with. And so that's why the remainder theorem, and this is my focus for today, why the remainder theorem is the best method for you to understand and make sure to understand why you need to know this, okay? And so I'll copy now the question again. But here, the original question states is 5x plus 4 divided by x, divided by x plus 1, like this. And I'm going to take this paper away now. Okay? And so when I'm doing the remainder theorem, the first thing I need to do in order to implement the remainder theorem is to find the possible zero that the x value that is going to exist. So for example, this is the value I want to test whether it's going to be a factor or not. So what I need to do is I'm going to take x plus 1 and make it equal to 0. And so by solving for x, I'm going to find out that x equals to negative 1. And after doing this very simple, little calculation, I could plug negative 1 into this equation, the main equation that I'm looking at right here, and see whether or not the remainder theorem is applicable to this. So I'm going to plug negative 1 into here. So it's going to be original question. Let me repeat it. X squared plus 5x plus 4. I'm going to plug negative 1 into here. So I'm going to plug negative 1 into these x's. So it's going to be negative 1 squared plus 5 times negative 1 plus 4. And if I do compute this, 1 minus 5 plus 4. And this will be negative 4 plus 4, which is equals to 0. And how the remainder rule works is that if the value is 0, then it is a factor. And which is the case for this? It's going to be a factor. And so we know as a fact that this value is a factor just by simply calculating with the basic arithmetic. Be aware though, sometimes the remainder theorem will test to see, and you might do this whole test and you might get a constant. So if you get a different constant, any value that is not 0 will not be a factor based on remainder theorem. So if I do calculations and I get negative numbers, or I get a fraction, or I get like 800, or whatever value that comes out of here, if this is not going to be 0, then I know as a fact it is not a factor, and I do not need to worry about that value. And so be aware that this concept of the remainder theorem is connected to a larger concept that you will be learning soon enough. So make sure to wait out for the video where I'm going to explain why the remainder theorem is so important. But the main focus around the remainder theorem, I do want to summarize in the end, is to find out whether or not that specific 0, which for this question was negative 1, x equals negative 1, will be a factor or x-intercept or whatever not you want to call it for the polynomial, for any possible polynomial, whether it's x squared or x to the 4th or x to the 5th, okay? And so that concludes my explanation for today around remainder theorem. Thank you so much for watching this video. Please do subscribe to our YouTube channel or like our Facebook page so that we can continue to make content like this. I hope you have a wonderful day.